Imagine stepping into a machine. You set the controls for a different time. Maybe you want to see the dinosaurs. Maybe you want to meet your great-great-grandchildren. The machine whirs to life and then, you're gone, propelled into the past or future. This is the dream of time travel. For centuries, humans have been fascinated by the idea of time travel. Stories about time travel have captivated our imaginations, but is it truly possible? Could we one day build a machine that allows us to navigate time just as easily as we navigate space? The concept of time travel is mind-boggling. It challenges our understanding of the universe and our place within it. The laws of physics, as we understand them, govern how we experience time. But what if we could find a way to bend those laws, to twist time to our will? Join me as we embark on a journey through the fascinating world of time travel, exploring the science, the possibilities, and the potential consequences of this captivating concept. Before we can delve into the possibilities of time travel, we need to understand what time actually is. We experience time as a linear progression, a steady march from the past, through the present, and into the future. But physicists see time differently. Einstein's theory of relativity tells us that time is not absolute. It is relative, meaning it can be affected by factors like gravity and speed. The faster you travel, the slower time moves for you relative to someone standing still. This is called time dilation. This concept of time dilation is crucial to understanding the possibilities of time travel. If we could somehow travel at speeds approaching the speed of light, we could theoretically slow down time for ourselves, effectively traveling into the future. While the idea of time travel may seem like something out of science fiction, there are some intriguing theories suggesting it might be possible. Two of the most prominent of these theories involve wormholes and the manipulation of space-time. Wormholes, as the name suggests, are theoretical tunnels that connect two different points in space-time. Imagine folding a piece of paper in half and poking a hole through it. The hole represents a wormhole, providing a shortcut between two distant points on the paper. Einstein's theory of general relativity allows for the existence of wormholes. However, even if they do exist, they are thought to be incredibly unstable and microscopic, making them unsuitable for human travel. Imagine a vast sheet of rubber. This sheet represents space-time, the fabric of our universe. Now imagine placing a bowling ball on the sheet. The ball creates a dip, a curvature in space-time. This is what massive objects like stars and planets do to space-time. Now imagine that the bowling ball is so heavy that it punches a hole through the sheet, connecting to another point on the sheet, or even a completely different sheet. This hole is a wormhole, a theoretical shortcut through space-time. While wormholes are theoretically possible, they are incredibly unstable. They would likely collapse the instant they form, unless we could find a way to prop them open using something called exotic matter. Exotic matter is a hypothetical type of matter with negative mass and energy density. While we have never observed exotic matter, its existence is allowed by some interpretations of quantum mechanics. If we could harness exotic matter, it might be possible to stabilize wormholes, making them traversable. Section 5. The speed of light. Another possible avenue for time travel lies in exploiting the relationship between speed and time. As we mentioned earlier, Einstein's theory of special relativity states that time slows down for objects as they approach the speed of light. Imagine a spaceship traveling at 99.999999% the speed of light. For every year that passes on Earth, only a few minutes would pass for the astronauts on board the ship. This is because time is relative, and time for the astronauts is passing much slower relative to time on Earth. If we could develop a spaceship capable of reaching and sustaining such incredible speeds, we could effectively travel into the future. However, the energy requirements for such a feat would be astronomical. Section 6. Building a time machine. While the theories of wormholes and time dilation offer tantalizing possibilities, the technology required to build a working time machine is far beyond our current capabilities. To create a wormhole, we would need to harness the power of exotic matter, something we have never even observed, and to travel at speeds approaching the speed of light, we would need to develop propulsion systems that defy our current understanding of physics. Building a time machine would require breakthroughs in our understanding of quantum mechanics, general relativity, and possibly even entirely new branches of physics that we haven't even discovered yet. It would be a monumental feat of engineering and scientific ingenuity. Section 7. The Perils of Time Travel. While the idea of time travel is undeniably exciting, it also raises a number of perplexing paradoxes and potential dangers. One of the most famous of these is the grandfather paradox. Imagine you travel back in time and accidentally kill your grandfather before your parent is born. This would mean you would never have been born, so you couldn't have traveled back in time to kill your grandfather in the first place. This creates a logical inconsistency, a paradox. Another concern is the potential for unintended consequences. Even a small change to the past could have ripple effects that drastically alter the present. The butterfly effect, a concept from chaos theory, suggests that even seemingly insignificant events can have major consequences over time. Section 8. Time travel and society. If time travel were to become a reality, it would have profound implications for society as we know it. Our understanding of history would be turned on its head, as the past would no longer be set in stone. The legal and ethical ramifications of time travel would be incredibly complex. Who would regulate time travel? What would happen to criminals who try to escape justice by fleeing to the past? These are just a few of the questions we would need to grapple with. Time travel could also exacerbate existing inequalities. Imagine a world where only the wealthy elite have access to time travel technology. They could use it to amass even greater wealth and power, further widening the gap between the rich and the poor. Section 9. Conclusion. The allure and implications of time travel. Time travel continues to captivate our imaginations, offering a tantalizing glimpse into the unknown. While the scientific hurdles to achieving time travel are immense, the very possibility fuels our sense of wonder and pushes the boundaries of our scientific understanding. Whether time travel remains firmly in the realm of science fiction or becomes a reality in the future, the exploration of this concept forces us to confront fundamental questions about the nature of time, the universe, and our place within it. It is a journey of discovery that is sure to continue inspiring and challenging us for generations to come.